Okay, let's get into this. When you think about massive industrial sites, power plants, chemical processing, temperature control is everything. It's not just about, being efficient. It's about preventing a total disaster. So today we're doing a deep dive into one of those tiny silent guardians. It's the NTI E-RTDS-PAR540-12IN pipe sensor. Our mission here is to look past the model number and really uncover the engineering story behind this little component.
And what's so interesting right from the start is how specialized it is. This isn't some generic off-the-shelf sensor. It's purpose-built to monitor temperature on a pipe surface.
On the surface, not inside it. That's a key distinction.
A huge distinction. And the
Yep.
12IN in the name, that tells you it's for large pipes. We're talking diameters from 6 all the way up to 12 inches. It has this adjustable clamp.
So right away, we know this is for serious high-capacity industrial lines.
Exactly.
So let's unpack the core tech. The listing is full of acronyms. RTD, what are we looking at here?
RTD stands for Resistance Temperature Detector. And the key ingredient, as the listing says, is platinum.
Right, it mentions 100 ohm P385 curve. That sounds incredibly specific. Is that some proprietary NTI thing?
No, and that's the point. That is the language of global standardization, which is absolutely critical in these systems. PT is just the symbol for platinum. 100 ohm means that at freezing, 0 degrees Celsius, its electrical resistance is exactly 100 ohms.
Okay, so that's the baseline.
That's the baseline. And the 385 curve, that's the crucial part. It means it follows the IEC 60751 international standard. It's a globally recognized calibration curve. So you, as an operator, you know its response to temperature is predictable and linear.
And that stability allows for, well, an absolutely astonishing operational range. I mean, we're talking about from a deep freeze of minus 58 degrees Fahrenheit
Or minus 50 Celsius.
all the way up to a scorching 540 degrees Fahrenheit. That covers just about every scenario imaginable, from refrigerated lines to, high-pressure steam pipes.
Exactly. And to cover that range while staying accurate, that's the real engineering achievement here.
Let's talk about that accuracy. The precision is defined at two key points, isn't it?
It is. 0 and 100 degrees Celsius. Those are the global benchmarks for verifying sensor performance. At freezing, the accuracy is impressive. It's within plus or minus half a degree Fahrenheit.
But that tolerance shifts a bit as things heat up. Near the boiling point of water, so 212 Fahrenheit, the spec says the tolerance widens to plus or minus 1.44 degrees.
A slight widening, yes, but still very precise for that temperature. And notice the physical setup. It uses a 6-foot, 3-wire lead.
And that third wire isn't trivial, is it?
Not at all. It's there specifically to compensate for the electrical resistance of the wire itself. It makes sure that the distance from the sensor to the monitor doesn't throw off the reading.
So it's all about data integrity.
Always. But that precision is useless if you can't get the data into this system. This sensor needs another component, the E-RTDT-1P62 transmitter, to talk to NTI's main monitoring platforms, like the E2D or E16D.
Ah, so it's an ecosystem play. It's not just a standalone part.
Correct. And it also has RoHS regulatory approval.
Okay, for those of us who don't spend our days reading compliance reports, what does RoHS mean in practical terms?
It means restriction of hazardous substances. So it certifies the device is free from things like lead and mercury. It's another layer of quality and safety assurance, which really matters for long-term infrastructure.
And that focus on quality and specialization probably explains the price. I see it listed at $135. That might sound high for a temperature sensor, but then you see related products for 2-inch pipes, 6-inch pipes. It's all about a tailored fit.
You've got it. You're not paying $135 for a general thermometer. You're paying to reduce risk on a critical 12-inch pipeline where a failure could cost millions.
That's the value.
So what's the big takeaway here for you, the learner? This NTI sensor. It's this balance of extreme temperature tolerance and globally recognized precision. It is a very specific, very robust tool for a high-stakes industrial problem.
So that leaves me with a final thought. Given that we need this level of detail, defining these tiny variations in accuracy at specific points like 0 and 100 degrees Celsius, what are the broader implications of relying on such precise data for predicting when maintenance is needed or for preventing catastrophic failures in these vast hidden networks of industrial pipelines that run our world? Something to think about.